All right, so next up is finding the midpoint, our segment bisector, or a perpendicular bisector. We want to put the nose on the point, on the end point, and you have to adjust the compass so that it is open more than half of our line segment. You're going to draw an arc above the line segment and below the line segment. You're going to put the end point on the other side, and you're going to draw an arc below and above. If you're using our bull nose compass, you're going to put your nose here, and you're going to make your slide at least more than half, and you're going to draw an arc above, same distance. You're going to draw an arc from the other end point above and below. Now what you're going to do is you're going to use your straight edge, and you're going to draw a line that connects your intersections above and below. Label your midpoint. So let's go ahead and label this segment A, B, and this we're going to label our midpoint, point M, and we're going to draw our perpendicular angle. Now keep in mind, our right angle theorem says if it's perpendicular, first of all, definition perpendicular says the lines intersect at a right angle. Definition of a right angle tells us it's 90 degrees. And if I have one right angle, then I have 4 right angles. All right, let's talk about this thought question. Why must the compass be opened to more than half of the length of the segment? On your mark it, set, talk. All right, so the conversation I heard is if it's not opened more than 1/2, then we don't get these intersection points above and below the line. We don't get these intersections above and below the line that are in line with this midpoint. So what's kind of cool, and we're going to talk about this in this next coming unit, is little do you realize that you are creating a series of triangles every single time that you do this construction. And we're going to talk about proving congruent triangles shortly, but you can see if this distance here is the same as this distance here, what kind of triangle am I looking at here? If this distance here is the same as this distance here, what kind of triangle am I looking at? Yeah, that is an isosceles. Because those two sides are congruent by construction. So we're going to start talking about this is a perpendicular bisector of not just this segment, but of the whole triangle. And this next unit has all kinds of properties about why this construction works. Questions about this one? All right, that's our midpoint, our segment bisector, and our perpendicular bisector all together.